Hey grade 12s, let's have a look at this question. Quite an interesting one. Not really that special, but perhaps on the challenging side. This was one of the assignments of my students that we discussed, so I felt since we've been discussing paper 2 material, just to get you comfortable on these very long and tiring, perhaps challenging sections, maybe if your confidence gets better here, you stand a very good chance of finishing the paper on time and essentially scoring as many marks as you can. So let's just do this question 6. Okay. I hope this thing has been marked already. They have handed it in or so. Otherwise, it would be a crime for me to show these answers before these things have been submitted. It would be a disaster. I just hope it's already submitted. Anyway, in the figure, B is the foot of a vertical tower, BA, and the 2 points C and D are in the same horizontal plane. Normally this gets shaded, but it's not a big deal. So these are indicated that they are 90 degrees to the horizontals. Now from C, the angle of elevation, remember, once we say angle of elevation is from horizontal up. Okay, of A is X, so this is indicated already. If BD is equal to CD equal to D units, so this is also indicated, and BDC is Z. We need to prove that AB is this expression. Of course, once we see a square root sign, there are two things. It's either we've had Pythagoras theorem or the cosine rule, because they talk about scale. In fact, both of them are derived more or less the same way, if not related somewhat. Now, if we look here, we see that there's a some change in the sign. So this is already spelling out a cosine rule. Now, cos of Z is this angle. So it means we've got a cosine rule applied for this triangle. But then how did we end up with AB? We can see that triangle ABC has a common side BC with triangle BCD. Can you see? So this means we need to find the common side BC, and we are going to use the cosine rule from this triangle. And once we get to that, we will see that, okay, if we get this part and we're looking for AB, we've got the angle. It's as good as 10 of that angle. It's going to be opposite over adjacent. So this whole thing, guys, already spells out exactly what you need to do. So if you make a habit of inspecting these expressions or these equations or identities, you will clearly know where to begin and how to begin. Yes, some questions are not so obvious for some reasons, which, you know, we call those higher grade questions. But other questions, even though they may be classified as higher grade, but most of the time the clues are right there within the question as to how you go about it, as long as you understand the procedure. Okay, we will start 6.1. We know that essentially CB squared, or maybe let's call it BC, is going to be equal to CD squared plus BD squared minus 2 times CD times BD times the cos of angle D. This is the cosine rule in triangle BCD. Sometimes I like to explain where I'm at so that nobody misquotes me or misreads me. So BC squared is equal to, this is going to be D squared times D squared minus 2 times D times D times cos of Z. So we move on, say BC squared is equal to, this is 2D squared minus 2D squared times cos of Z. So we can factorize here. BC squared is equal to 2D squared is the common factor. We get 1 minus cos z. Of course, what guides me is because I saw that there's a 1 minus cos z and there's a 2 out as well. So this makes sense to do. So what do we do now? Take the square root of the left hand side, and whatever we do to the left hand side, we must also do to the right hand side. So BC is going to be equal to, the square root of D is just going to be D into 2 is irrational there, so we leave it in 1 minus cos of Z. Can you see we already have half of the stuff done? So what's missing is just the tan of x, which is very easy. We can say then, we understand that tan of ACB is going to be equal to the opposite AB divided by CB or BC. So what is this? This is just the tan. Okay, maybe this is crazy. To put a reason here is a bit unfair, right? Right. So we can just say in triangle ABC, we understand that tan of ACB is going to be that. We substitute. So we get tan of x is equal to AB over BC, which is just D, times the square root of 2 minus 1. Sorry, 2 into 1 minus cos of our lovely Z. What can you say? So of course this is fractions now. This is over 1. We cross multiply to isolate AB. Therefore AB is equal to D times the square root of 2 into 1 minus cos of Z times the tangent of x is proven. Nice and easy. So once you know what to do, please jump in and get it done. It's not a big deal. All right, let's get to the next question. 6.2. We need to prove that AB again can be defined this way. But now what do we see here? We see sine of angle Z. So obviously this is suggesting we're going to use the sine rule in this triangle. Then we've got tan of x, of course, it's the multiple there. But now we've got cos of z over 2. So what happened here? We know that if this is an isosceles triangle, that angle P must be equal to that angle C in this triangle. So we can work out that angle first. So we can say in triangle BCD, we understand that angle, say BCD plus angle CBD plus angle D, we should be getting 180 degrees. This is the sum of 3 angles of a triangle. All right, so we will say, but we understand that angle CBD, let's say BCD, is equal to angle CBD, right? These are angles opposite equal sides, given that CD is equal to BD equal to D units. So this is where we got this from. Now what does this mean? It simply implies that if these are equal, we can represent the sum here of the same angle BCD, if we like, plus Z is equal to 180 degrees. So therefore, if we want to solve BCD, it's going to be 180 minus Z divided by 2. So 180 divided by 2 is 90 degrees. Z divided by 2 is just going to be Z over 2. Easy. So that was the key to some of the challenges here. Now what do we say? We can say then, We understand that BC, which is the common side, is divided by the sine of the angle opposite that, which is D, should be equal to any of the other sides that we choose. So we're going to say here BD divided by sine of angle BCD, since we worked that out. So this is the sine rule. The sine rule in triangle BCD. Of course, usually the topic, if nothing else comes in, we're still talking about that, but be very careful. We need to be clear. Perhaps to say then is too soon. We can say also. We know this. It's also applicable to the triangle. So this implies that BC is what we want in terms of this other side now. So this is going to be the sine of angle Z equals BD. This is D divided by sine of 90 degrees minus Z over 2. Okay, so this implies, we cross multiply that there, it implies that BC is equal to D times sine Z, all divided by, remember this is now a cofunction, it turns out to be cos of Z over 2. Oh, great, because now we have all of that. So we can say since AB is equal to BC times the tangent of X from above, of course, when we solved here, we saw this. Yeah, perhaps I should have kept that BC before I substituted, but it's not a big deal. You can say in question whatever, it's not a big deal. It follows that AB is going to be, now instead of BC we put D sine Z divided by the cosine of Z over 2 times the tangent of X. Now this is over 1. Therefore, perhaps we may say implications before conclusions. Okay, therefore we can say this is going to be D sine Z times 10x. Remember, numerators multiply as well as denominators. Okay, it's done. So again, a very simple question, but one needed to understand how triangles work. As I often said, folks, if you don't know triangles so well that you can do whatever with them, then you are committing suicide doing maths. Because triangles, you can see there's even more notes I added for you guys on triangles. And that's just, to scratch the surface. There's more than I mentioned to you. So please, folks, there are no excuses here. Just get your job done. Now the last question is very easy. We need to find the area of BCD, which is this triangle on the floor. So we are given angle D, which is Z. This is the included. We've been given the sides. So this is easy. Area of triangle BCD is going to be half CD times BD times the sine of angle D. That's the area rule. So this is a half. CD is now 500. BD is also 500 times the sine of 80 degrees. So we just do that by punching the 0.5 into 500 squared into sine of 80. Just be careful with brackets, using the calculator to make sure the calculation is right. So I'm getting 123,100, 972 decimal places, meters squared, because this is 500 meters. So this one is over in just an instant, okay? So guys, there's nothing really special here, but of course the trick here is that sometimes when you get weird angles like these ones, they're just weird. So think about, where could this have come from? What do I know that may have led to this? Of course, it may not be so obvious at first, because you end up with stuff like this. But you can really be happy that if I've got sine and there's 90 cofunctions, because remember, we are still proving identities. These are nothing but identities. Oh, I forgot that I didn't activate my screen right there. Okay, not a problem. So remember, three-step approach, folks. If you don't know anything, please internalize that. Believe me, whenever you get stuck, think of it and see what you can do with it. You'll be surprised how so many problems you will just solve in an instant, if not at least within reasonable time. Anyway, folks, I just wanted to share this question. I should see you next time. Bye-bye.